Hi everyone, today in Integrated Math 2, we're going to go over Chapter 11, Lesson 2. Here are the objectives. Make sure you write them down in your notes. Alright, let's go over angles and arcs. So, a central angle of a circle is an angle with a vertex in the center of the circle. Its sides contains two radii. Remember, radii is when we're talking about the plural form of radius. And that's of a circle. So angle ABC is the central angle of circle B. And don't forget that circles all equal 360 degrees. Think about it as two protractors being added together. One protractor goes to 180 degrees, which would be forming a straight line. So we would need to double that. 180 times 2 is 360 degrees. So that's where that comes in. Alright, so sum of central angles. The sum of the measures of central angles of a circle with no interior points in common is 360 degrees. What we're saying here is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is all going to equal 360 degrees. Just remember, all circles equal 360 degrees, so that's the same with their angle measurements. An arc is a portion of the circle defined by two endpoints. The central angle separates the circle into two arcs with the measures related to the measure of the central angle. So notice here we have our 2 points, P and R. And then we have our radius, in our case, which is Q. So we have this red arc, which is smaller than our blue arc here. So this is a larger arc, and this is going to be our smaller arc. But we have two arcs. So let's go over arcs and their arc measurements. A minor arc is the shortest arc containing two endpoints on the circle. So recall here, we have our endpoint A, and we have our endpoint B, and we have our radius C. So we have the blue arc, and we have the red arc. And we want the shortest arc, which in our case is going to be our red arc. So when we are writing these down and showing that it's a minor arc, notice I only use the letter A and B. You're going to see the difference between the minor arc and the major arc when we write that. So to indicate that it's a minor arc, we're just going to use the endpoints. In our case, for example, it's A and B, which is equal to the measurement of angle ACB, which is equal to x degrees. Alright, so a major arc is the longest arc containing two endpoints on a circle. So our endpoints are A and B once again, and our radius is C. We have our blue arc and we have our red arc. The difference being that our red arc is the one that we want to look at now because that is our longest arc. Our blue is our minor arc. So our red arc is the longest arc, and notice the difference of how I'm writing this. I'm saying the measurement of major arc A, D, B. And notice I have this other point here, but I'm not talking about the arc in there. It's just to help indicate where it's at. So, and because we're talking about a major arc, I need 3 letters. So, the measurement of major arc ADB is equal to 360 degrees, because that's the total for a circle. And we're going to subtract that from the minor arc AB. So we have, when that's simplified, it's 360 degrees minus x. X just being the degrees once again. Then we have a semicircle, which is an arc with endpoints that lie on a diameter. So The measure of the semicircle is 180 degrees. That forms a straight line, which means they are both equal. So there's no major arc or minor arc. The way we're going to write this is the measurement of arc ADB is equal to 180 degrees. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So if angle 1 is congruent with angle 2, then we also know that minor arc FG is congruent with minor arc HJ. If the angles are congruent, so are their arcs. And that goes vice versa. So arc FG is congruent with arc HJ, then I know that angle 1 is congruent to angle 2. So next we have the arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So here we have the measurement of arc XYZ, so I'm talking about this arc right here, or this, is equal to the measurement of minor arc XY, which is this portion, plus the measurement of minor arc YZ, which is this piece here. So when we add these two arcs, we get this bigger arc here. That's all it's saying. Alright, then we have the arc length. The ratio of the length of an arc L to the circumference of the circle is equal to the ratio of the degree measure of the arc to 360 degrees. So you can either set this up as a proportion or an equation. So the proportion would look like this, L divided by 2 pi r, which is equal to x divided by 360 degrees, or you could put it into an equation. As an equation, L equals x divided by 360 times 2 pi r. And that's it.